Anyways, because I've not shifted up or down, the y-intercept's at 3. So that means my a value is 3 times and now then I'm just thinking here. If it goes from 3 up to 9 in the y values, what's happening? Yeah, it's being squared or it's being tripled each time. So we could go with 3 times 3 to the x. Do we follow that? Okay, but is that a choice? No. Did you guys figure it out to here and then get confused maybe? Is this where everybody understand? That works too. That works too. I'm in with that. So now then we go to our exponent rules. I am multiplying powers. Do you guys remember our exponent rules when we multiply powers? I'm multiplying powers that have the same base. They both have a base of 3. So we can keep the base the same, and we could add the exponents. Well, this one doesn't have an exponent, so it has an understood 1. So if I added those exponents, 1 plus x, we could rewrite as x plus 1. That's me figuring it out without knowing the multiple choice. Like Lydia was saying, you can just start plugging in x's, right, and figure out how it works. So see, this is good stuff because we're getting a little bit of exponent review in with our work. Yeah. Okay. Sorry. Really excited. Anything else? We're having breakfast for supper tonight at my parents' house. I don't remember the last time I've had breakfast over there. It might have been when I lived over there. That's not true. It would be, I know when it is. It's last fall break at our Disney World trip. We had breakfast where Mom cooked it one morning. And that's it. Anyways. Yeah. Breakfast. If I look at I, first thing I notice, horizontal asymptote's been shifted. So I know it's going to have a minus 1. J, there is no horizontal asymptote shift. So the next thing I'm looking for is the y-intercept. So y-intercept is 2 times. And now, if I started working to the right, I'm decreasing in power. So to me, that one's harder to see because they don't hit right on crosshairs most of the time. Like, I could get a good guess. Like, to go from 2 to 1, I think that's being halved. And then from 1 to here, I think that's at a half. But I don't know that's at a half. So in my head, I'm thinking it's probably increasing, being multiplied by half every time I increase by x. But I can find out for sure if I go to the left. So right here, if I go this direction and up, what happened? It was doubled to 4. And if I go here again, it's being doubled to 4. So again, and I don't know what the multiple choice are because I'm not looking at what those are. But I would think that it would be 1/2 raised to the x. Is that a choice? And so every time I'm going right 1, it's being multiplied by half. Multiplied by half. It could also be written as 2 to the negative x, right, if that was a choice. I didn't know which one it was.
You can also do K.
Yeah, I sure could. So what's my big telltale sign on K? It is negative, it's decreasing, but even more than that, the horizontal asymptote has been moved. Do you know what I'm talking about when I say that? So where's the horizontal asymptote at?
3.
It's at 3. So whatever my equation is going to be, it's going to have a plus 3 in it at the end. Has to. That's the only way I could move the horizontal asymptote. Okay? Then from there, so when I have a horizontal asymptote, you can't use the y-intercept the same way. So like, I know it crosses at 2, but I can't be sure it's 2 times something. It doesn't work that way when I've shifted up or down. Right? That's the only time I can't do it that way. So then the next thing I would look at is like, what's happening? So like here, when x is 0, I'm at 2. And then when x is 1, I'm at 0. And then the next time, it grows to being at, I don't really know where it's at. I'm going to guess it's like at negative 6. This is one of the trickier ones. I would probably need to look at my multiple choices and do some plugging in. So let's see if I can find my list. Here it is. So the first thing I'm looking for a plus 3. And it looks like there's only one of them that has a plus 3. It's the integral sign. Right.
Is that the L looking thing?
It is. It looks like those things that are on the dishes at Huddle House.
Is it the L looking thing?
It's this.
What's the
This thing.
dishes?
So, anyways, my point, I would plug in values here. Like, I think this is going to work because it has a plus 3. So I'll just plug in to find out. So like, if I plugged in x is 0. So if I plug in 0 here, what does that give me? Well, negative 3 raised to the 0 power is 1. Anything raised to the 0 power is 1. Okay? So there's a little review too of exponents. So this is 1. But then this 1 has to be multiplied by the negative 1 out in front. Notice, there's a difference between negative 3 to the x and negative 3 to the x. They're different. Did I talk about this yesterday in here? It's different. And so there's an understood negative out here. So the 3 to the x is 0. 3 to the 0 power is 1. 1 times negative 1 is negative 1. Negative 1 plus 3 is 2. So I plug in 0, I get out 2. That works. Now if I plug in 1, 3 to the first is 3. 3 times negative 1 is negative 3. Negative 3 plus 3 is 0. And so it works for those 2 points. That's normally a pretty good sign that we're going to be good to go from there. And that's really the only 2 points I know for sure. Because I told you if I plugged in 2, I think it's at negative 6. But I don't know that. But if I plugged in 2 here, 3 squared is 9. 9 times negative 1 is negative 9. Negative 9 plus 3 is negative 6, which is what I think the next one's going to be. Was that confusing enough?
Enough for me.
Okay. What did we get for G? Copyright. Copyright symbol. And H. It is the and symbol. I can't draw it. Don't ask me to draw it. The fancy and. Anything there we need to talk about? Look at 6, and we've kind of already talked about this one. Petra believes that graph L represents the parent function y equals 3 raised to the x after it has been shifted to the left 1 unit. Pierre believes the graph L represents the parent function y equals 3 raised to the x after it has been vertically stretched by a factor of 3. Who is correct? Give a convincing reasoning. So if I look at this question, what would it look like if I vertically stretched it by 3? How do we vertically stretch something? Multiply it by 3. Well, did we talk about how we could simplify this? 3 times 3 to the x. This is equal to 3 to the... So does that make sense if I vertically stretch 3 to the x by 3? Does that give me this graph? It does. What about what Petra was saying? How do we shift a graph left 1? So shifting left or right is by adding or subtracting where? On the outside or inside of the function? Inside. Inside affects x's. If I'm going left or right, that's changing the x's. So if I needed to go left 1, how do I go left? I would need to, on the inside, I need to add because it does the opposite of what we think it should do when I'm on the inside. So here, the inside of the function is up in the exponent. And so if I want to go left 1, I would need to add 1 on the inside. So who's right? Both.
Would you give a convincing reason?
Show the math and like what I explained in words, like what I said out loud. If you could write something like that. Here's what they wrote. Stretching by 3 means we have 3 times 3 to the x, which gives 1 extra factor of 3. So we really have 3 to the x plus 1. And that 3 to the x plus 1 is a horizontal shift left 1. They're just saying they're the
You
same.
seem like really excited that they both correct.
Is that not cool?
Yeah. That's why I got confused when I said.
It's so like there, exponential functions, they have multiple transformations you could do to get the same graph. That's what's kind of weird. It's kind of like if I took the graph y equals x, like we don't talk a lot about linear transformations because you already know how to graph a line. If it's in slope-intercept form. But just go with me here for a second. Pretend like the purple here is the line y equals x. Now what if I shifted the graph up 1? So now then the red line would be y equals x plus 1. But now what if I shifted the graph, go back to my original, what if I shifted it left 1? What would that look like? So y equals, I'm going left 1, so on the inside I would need to add 1 because it does the opposite of what we think it should do. So like linearly, left is the same as up, and right's the same as down if I shifted it that way. So it, similarly, the exponentials have multiple transformations that can give me the same graph. I at least had some I sees and aha moments, so I'll take it. The limit as x approaches negative infinity of g of x. So as our x's go to negative infinity, the y's go to 6. They approach the horizontal asymptote. What about the limit as x approaches infinity of g of x? As we go to the right, the y's go to infinity. They go up forever, without bound. So what they want me to do is take 2 raised to the x minus 1 and rewrite it. So this is all coming down to knowing your exponent rules. So if I have exponents that are being subtracted, I could rewrite that as 2 to the x over 2 to the first. Do we know that exponent rule, or do I need to review that? If they're being subtracted, that means it could have been being divided. Right? If I had x to the 6th divided by x to the 4th, we should have learned to write this as x to the 6 minus 4. And so I'm just working backwards. Now I'm going, they're being subtracted. Now I'm writing it as a ratio. And now if I've got 2 to the x divided by 2 to the first, well, 2 to the first is just 2. And so if I'm dividing by 2, that's the same thing as multiplying by half. So this is 1/2 times 2 to the x. And now then I have written it as a dilation. It's a compression, right? 1/2 times 2 to the x. Questions? Okay. 4, write an equation for an exponential function that is increasing and concave down over its entire domain. Different from the ones we've seen in this lesson. Here's one they came up with. So what has to happen for it to be concave down? Has to have a reflection. There's no way it can be concave down without this. Because whether it's this way or this way, they're both concave up. This is concave up increasing, this is concave up decreasing. So if I've got to reflect it. So if I reflect this one would be concave down, but it's decreasing. So I need for it to be concave down, but increasing like this. So that means I need this to be a fraction, less than 1. That's all that matters. I need a negative here to make it be concave down. I need a fraction here. That way it's increasing from left to right. Because this one is decreasing from left to right.
I would have gotten that.
I would have done that.
Because you figured out